Hi, I'm Michael Forrest, and I just spent another day on RealtimeSwift. So this is part 3 on my SwiftUI-style declarative rendering engine. So today I made some progress into implementing modifiers and the environment, and actually managed to render the webcam onto the screen, kind of. So it is late in the day, but I just want to sort of explain my progress. So this is the goal. So my app state is going to have so I've got this app state here, and this has a source registry. And this is going to be passed into the environment so that the pixel buffer layer can just kind of say, okay, I want the USB video source. And the framework will handle if that's missing and that kind of thing. So in my app state, I'll create this source registry, and this kind of belongs to the framework. And then here I'm just going to do a discovery session, look for external cameras today, and just register any cameras that I find. And then CameraSource, don't worry about this too much, but this is just like some standard AV kit stuff. So we grab the device, we create an AV capture device input, we add the input, we make a data output, AV capture video data output. We set the sample buffer delegate to ourselves so that when we go capture output, did output sample buffer, we can grab the image buffer from that, and I'm just going to wrap that up in a core image. Then we add the output and just start the session running. So that's now going to be getting camera frames. I also have to set some permissions, and there's a privacy key that you have to set as well. But I'm still displaying presentation.date here just so that it's going to update every session. So what is this? So what are we doing here? What's this environment function? But let's start off by actually talking what the environment is in our context. So the environment is managed during rendering and passed into all these resolve calls. So basically, so I create my environment here. I think this is where it belongs. So this is my real-time renderer, and so I've created an environment here. Basically, it's going to just, whenever it resolves the body, it's just going to pass the environment in. And then that resolve, the top level resolve that's kind of used by, it's an extension on real-time view. Basically, it's this sort of growing list of conditions where we've either got leaf nodes, or we've got containers, or we've got, some tuple stuff. We've got this optional thing that we did yesterday. But basically, the environment's going to get modified. It's just basically the environment's getting sent into every one of these different kinds of, so arrays resolved also gets the environment. So it's just passed down. And I'm hoping that's it for all the things that need to be explicitly passed around for now, but we'll see. So here's the RealtimeEnvironmentValues implementation. I think I'm just going to rename this to real-time environment. I just kind of took my keys from somewhere else. So it defines the keys and stores them. So we've got storage, object identifier any, and then we can key that on subscript. And it's got this little kind of merge function. So it's just basically a dictionary full of values and keys, which is what you'd expect the environment to be. And then there's a property wrapper so that we can access it. I haven't actually tried this yet, but like SwiftUI has environment, this is how the app environment will work. So hopefully I can access stuff from within views if I need to. So let's look at how the environment can receive values through a modifier. So let's talk about the environment modifier. So how does this work? So we've got environment appstate.source registry there. If I just source registry there. So basically, in this case here, we are keying. So this first example of environment, we're just keying the object on itself rather than passing in a key path. So that's what this k.value equals k. So k is a real-time environment key. And in this case, the value is the key so that we don't have to give it a specific value. And then this calls modifier. So modifier is something that I've added, right? And so modifier looks like this. So it's an extension on real-time view, so it can be accessed from any view, and it gets a type, and it just basically wraps up the content, and the modifier just sticks them together in a sort of generalized way. And we need this environment function to return some real-time view, so we need to sort of make a special view that's going to do that. So that is, we're going to return this special real-time environment key writing modifier. let's not get ahead of ourselves. So real-time environment key writing modifier conforms to a more general real-time view modifier type, and then this real-time view modifier type just basically says, okay, it's got body content, and it defines a body function, so it's sort of like it's it's just another protocol so that we can kind of identify view modifiers. And then here is the body. So the body of this is actually going to wrap up a real-time environment injector. So it's another nested component. And this is something that ChatGPT suggested, and it kind of seemed right. And I'll probably, now that I'm explaining this, I think this is right. It seems like a lot of nesting, but we've sort of turned that kind of wrapper that just associates the two values into something that's then like a concrete view type, which can then be sort of stuck in the hierarchy and do its stuff inside body, storing with itself the key and the value. So this is kind of now a view that can be sort of passed around, in the same way. And then this is a primitive real-time view, which means that its body type equals never, so that we're never going to call body on this, because really all we want is this for it to support real-time modifier view, so that it's going to support this resolve function. Right, so this is all we're trying to do here. And so, this real-time view, this resolve function happens. This is like in one of my conditions, I'm going let modifier. So basically, it's a primitive, so that means body is never, which means it kind of falls into this block instead of recursing. I was getting some stack overflows when I didn't implement this. But if it's a real-time modifier view, which I think that's general, that's going to work for all our modifiers, then we can resolve that modifier. In this case, when we resolve that, we get our real-time environment key writing modifier, or injector, I think. Let's see. It's sort of... I do think real-time modifier view is something the framework should handle, but I need to keep an eye on this. I need to keep an eye on all this. Anyway, we know we can call resolve on here, and in our environment, this is actually going to take us to the actual implementation, which is we grab the environment as a variable, we update it, and then we pass down that newly updated environment, and that's the mechanism through which the environment gets updated by that modifier, fundamentally at resolve time. So now that we've got that, how do we get the camera feed up? Well, for today, that pixel buffer layer that you saw just resolves like this. So the pixel buffer layer takes a name, that's all it takes. I think, is that in here? Let's go pixel buffer layer. Just has an init that takes the source name, right? But then when that resolves, all we're going to do is look in the environment for that registry. And I was not quite sure. With subscript, I'm not sure what happens if something's not there. So I should probably know that by now. But basically, I'm looking for that in the registry. I'm looking for a source with that name. If I find it, I return a pixel buffer render node. Otherwise, I'm going to return a source unavailable text node for now. And then we can sort of think about that behavior as time goes on, because that's going to be some app, some UI that we're going to need to figure out. So that returns a render node. And then the render node literally just, when it's asked to render an image, it just basically checks if that source has got an image, which you remember was set by that camera data output callback. And then it just passes that through. It's got the pixel buffer, it passes through the source image, and we're basically, we've got something there. So time for a demo, get ready to be underwhelmed. So we'll come into here and I will run the project and we'll see what we get. And we get, okay, oh wait, I can't see, we're not seeing it. Let me just make sure that I am showing you add windows. We want to add this. Right, here it is. So it's basically updating every 1 second, because I think I need to figure out where my 30 frames a second is coming from still. But basically that's it. You can see we've got two nodes here. We've got the ZStack render node, we've got a pixel buffer render node, we've got a text layer render node up there. And it is putting video on the screen, but also it's like firing up all the cameras on my machine, fired up continuity camera, because every camera it finds that's external, it just connects to the data output, which is definitely not what we want. So yeah, I think our framework is going to handle like starting and stopping those video capture devices on its own, so that it sort of keeps them going for as long as it needs, but then if nothing's using them, it can fire them down. We will get to that another day, but that's sort of quick and dirty, real time, if you can call it real time, once a second updating video feed. Right, I made this video using QCam Presenter, which is the app that I'm building this framework to support. You can try that at qcam.app. And if you want to see what the script looks like that I just ran through, it is like this. So I am able to do this sort of markdown. I just kind of authored these little markdown style slides. I can sort of change them like that. I can sort of pick from some different layouts really quickly. I can paste in screenshots. I can choose whether or not I'm picture-in-picture per screenshot. I can sort of put these this is with the full screen slide layout. I sort of grabbed my notes along. This is all coming into the teleprompter, which I'll show you in a sec. And I've got all this, and then I did a few Xcode screen shares as well, so you can see these are sort of going to specific line numbers of specific files, so that I don't have to like remember everything. I can just like get my thoughts together ahead of time and then hit record, and then when I'm presenting, I've got my teleprompter up here, and I can sort of annotate stuff on my iPad here. So I think I've got something where it's not. I think it's not showing the drawings when I'm doing this second camera. We'll figure that out. But yeah, so when I draw, I'm doing that on the iPad, so that's just coming through. You can try QCam right now at qcam.app/download. No strings attached. Thank you. No strings attached. Thank you very much for watching, and please subscribe to kind of keep seeing these devlogs, and see you soon, and see you on Reddit hopefully as well. There's been some good discussions there. I'm learning things, and I'm seeing people that are sort of interested in this, so that's always encouraging. Thanks for watching. Bye.